Coulomb's law. Coulomb's law states that for the charged particles or objects that are compared with the distance between them, there's a force. Here in this lesson today, we are talking about Coulomb's law. Between any two charged objects, between these two charges, we have a force. And since these two charges have a distance between them, this force has a relation with the magnitude of the charge and the distance between them. This is the main idea of our lesson. Recall now from the Newton's law of gravitation. All of us know the Newton's law of gravitation, that force is equal G times mass of the first object times the mass of, or mass sub 1 times mass sub 2 over d squared. This is the Newton's law of gravitation, that the gravitational force between two objects with mass 1 and mass 2 is proportional to the product of the masses and inversely proportional to the square of the distance between them. This is, as you remembered, F is G m1 m sub 1 m sub 2 over d squared. If we have any two masses, mass 1, like this is the first mass and this is the second mass, between these two masses there's a distance. Now, if there's two masses have a distance between them, there's an attractive forces between them. This attractive forces, I can find it by multiplying or the product of these two masses over the square distance between them times a constant which is G, or 9.8. So between these two masses, we have what? We have an attractive force. Here also, for the charge, we have the same. The Newton's law for any two masses. But for the charge, we have a law which we called it Coulomb's law. Now, the electrical force between any two objects obeys a similar inverse square relation with the distance. So as we have the force between two masses, we have a force between two electrical charges. The relationship among electrical force, charge, and distance, we called it Coulomb's law. So between force, masses, and distance is Newton's gravitational law, and between electrical force, charge, and distance, we have Coulomb's law. This Coulomb's law, discovered by the French physicist Charles Coulomb in the 18th century. For charged objects, the force between the charge varies directly as the product of the charge and inversely with the square of the distance between them. So how the formula will be? It will be like this. The force is, there's a constant, let's like G. Later on, we will talk about this constant. They are product. So as I told you, the force between these two charges, between us, the magnitude or the quantity of the first charge times the quantity of the second charge over the distance of the square distance between them. So this is the formula. F is equal to K times Q1 sub 1, Q sub 2 over D squared, whereas D is the distance between the charged particles. Q sub 1 represents the quantity of charge of one particle. Q sub 2 is the quantity of charge of the other particle, and K is a proportionally constant. Now, after that, I will tell you about what is K. Now, the SI unit of charge. Now, let's talk about the units now. For the force, as you know, it is in Newton. Now, For the D, it must be in meter. Now, what about the unit of the charge? For the masses, we said it's in kilogram. Now, what about the charge? The unit or the SI unit for the charge is C, or we say it Coulomb. Like I say, I have 5 times 10 to the power 5 coulombs. This is the quantity of the first charge, or the quantity of the second charge. And don't forget, as I told you before, a charge, it must be a whole number times the charge of an electron. As we said in the previous lesson, that a charge is a whole number, 1, 2, or 3 Coulomb of the charge of the electrons. This is, so if like Q1, it could be 5 times 6.24 times 10 to the power 18. Q2, as an example, it is 9 times 6.24 times 10 to the power 18. I will not give you this long number. I told you only if Q1 is 3 times 10 to the power 18 as an example. This one, it is the quantity of Q1. So to find the force, I give you the quantity of the first charge, the quantity of the second charge, the distance between them, and also you can find the force. But before you find the force, you need to know what is K. In the Newton gravitational law, we say that the constant is G, which is 9.8. But what is K here? Let's see now what is K. K now, this proportionally constant K is similar to G, which is equal 9 times 10 to the power 9. 9 times 10 to the power 9. This is the magnitude of K. The unit of it is in Newton per meter squared over Coulomb squared. From where we bring this unit? We say that the force here, let's make this one, please. We say the force is K times Q1, Q2 over D squared. Let's write them now as a unit. Newton. The unit of K, we don't know it. We have to find it. Let's keep it as, sorry. Let's keep it as K. Then the unit of the charge is Coulomb 1. Is Coulomb times Coulomb over meter squared. So it is Newton times meter squared equal Coulomb squared times K. So the unit of K, it will be Newton per meter squared over Coulomb squared. So don't forget, the unit of K is Newton per times meter squared per Coulomb squared. Is it clear?
Yes, teacher. Yes, teacher.
Okay. So here, the constant K in Coulomb law is equal to 9 times 10 to the power 9 Newton per meter, meter squared over Coulomb squared. So if a pair of charges is one Coulomb, let's, as an example here, imagine that we have two charges. Another one. The first one, the quantity of the first one is 1 Coulomb. The second one is 1 Coulomb. The distance between them is 1 meter. So what is the force will be? Let's say that the force is K Q1 Q2 over D squared. So the force is K, which is 9 times 10 to the power 9. This is K, the constant K. Q1, it is 1 Coulomb. Q2, it is 1 Coulomb over the distance between them is 1. So if both or if the quantities of both of the particles are 1, 1, and the distance is 1 meter, so the force of repulsion between the two charges will be 9 billion newtons, or 9 times 10 to the power 9 in Newton, or 9 billion newtons. So if you have two particles, both of them are charged with 1 Coulomb with a distance of 1 meter, so the force between them, it will be 9 billion newtons. Now, let's see now. So at the beginning here, we said like the Newton's law of gravitation is like Coulomb's law. They are similar in things, but they have a difference and some difference between them. Let's compare and contrast between them here. The Newton's law of gravitation for masses is similar to Coulomb's law for electrical charge. Whereas the gravitational force of attraction between the pair of 1 kilogram masses, okay, before that, look at these two formulas down here. The first one, as you see, sorry. The first one now, this one here, this is for the Newton, and the second one, this is for the electrical charge. Now, the first one, the force between, it's talking about the Newton's law, is talking about the force between two masses. So, F here, the Newton's law is between two masses. So the difference here that they are product of masses, but in the Newton's law, in the Coulomb's law, they are product of charge. Both of them here are of an inverse square laws. They have a distance, I'm talking about distance between the two masses, distance between the two charges, and they are inversely proportional with the square of the distance. This is for the Q and for M and for D. Now let's about G and K. G here, it's a small magnitude, it's only 9.8. But the constant here for the Coulomb's law, it's a very big, it's 9 billion. Here it's only 9. Here it's 9 billion. Now, so because of that, if you talk about masses, 1 kilogram with a distance of 1 meter, you will find that the force between them is only 9 newtons or 10 newtons. But if you take, like, so here, if you have 1 kilogram with 1 meter, if you find the force, you will find the force here is only 9.8 in Newton. But for the second one, if you have 1 Coulomb with the distance between them is 1, you will find now the force here is 9 billion in Newton. So what does it mean? That means the force between the two quantities, the two charges are a large magnitude, as a very big one. It's 9 billion Newton. But between two masses, it's only 9.8. So it's like comparing with the force, it is a small magnitude. Another difference here, that the force between, or the force area between the two masses, only it will be attractive, or to be attraction only. I can say they are attractive to each other only. All of us know that we have a gravitational force with the Earth. We have an attraction, we have an attractive force with the Earth, as an example. But in the electrical force, it's not only attractive, it could be repulsive, as we said before, because the two charges, it could be positive. So we have an repulsive force. It could be positive, it will be an attractive force, and it could be negative. So also we have an repulsive force. This is it now. By now we compare and we contrast, we say the difference and alike things between the forces between two masses, or between the Newton's law and Coulomb's law. So whereas the gravitational force of attraction between a pair of 1 kilogram masses is extremely small, and the electrical force between a pair of 1 coulomb is extremely charged, as we said before here. And the greatest difference between the gravitational and electrical forces, that for the gravity, it's only attracts, as we said, and for the forces, it could be attract or repel according to the charge of the quantity. If they are the same, we said it is repel, or it will be repel, and if they are different, it will charge. Now, I'll solve with you one example here, and tomorrow, inshallah, we will continue. I'll just give you an mathematics exam here. Let's have another page. Okay, so let's share. Now, there's a positive 15, or it's already Look at here. Now let's add the second one. For the second one here, if you have two charges, okay, let's have this one here. This is the first charge, and the second, this is the second charge. These are the two objects that they are charged. The distance between them is given, which is 0.3. So the distance now, 0.3 meter, the distance now is between these two objects. Now, the first object, its charge is 1. Now, this one, but it cannot be written here. This one is 1. The unit of it is 1. It is 1 microcoulomb. It's sort of like this. This is micro. Micro, it's a small magnitude, which equal 1 times 10. Sorry. So the magnitude of micro, don't forget, it is 1 times 10. 1 times 10 to the power negative 6. This is, we said it is microcoulomb. So MC, it's mean 1 times 1 times 10 to the power negative 6 microcoulomb. Micro, it's a very small magnitude. Micro, you know them, I think. Now millimeter. If you say millicoulomb, it is 1 times 10 to the power negative 3. If I told you microcoulomb, it is 1 times 10 to the power negative 6. So millicoulomb, it's like millimeter, 1 times 10 to the power negative 3. Microcoulomb, it is 1 times 10 to the power negative 6. So here, the first object here, its charge is 1 microcoulomb, and the second one is it's also 1 microcoulomb. Find the force now between them. The force is Q1, Q2 over D squared. Now, so the force is Q1, it is it is 9 times 10 to the power 9 times Q1, it is 1 times 10 to the power negative 6 times. I want you please just wait 1 minute here. So the force is K Q1 Q2 over T squared. So it is 9 times 10 to the power 9, which is K. This constant. Q1, it is 1 micro. Q2, it is 1 micro over D squared, which is 0.3 squared. So let's multiply. 9 times. Here you have at 9, let's now add the powers. 9, negative 6, and negative 6. What does it mean? It's 9 to the power 9 times 10 to the power negative 3 over. Down here, it is 0.3 squared can be written as 9 times 10 to the power negative 2. So if you put them, it will be 0.1 in Newton. So the force now between these two charges is 0.1 in Newton. Is it clear? Yes, grade 11, is it clear?
Why is it
Yes,
divided
teacher.
like 10 to the power -2?
Okay, here, wait, please. Here, as you see, it is K, Q1, Q2 over D squared. D, it is 0.3. 0.3, it can be written as 3 times 10 to the power -1 squared. It is 9 times 10 to the power -2. And if you're multiplying the numbers in the numerator, which is 9 times 10 to the power -3 over 9 times 10 to the power -2, okay, if you multiply them now here, you will say that the answer is 1 times 10 to the power -1. It is 1, and this is like this, because you put them up, so it will be 0.1 Newton. Now, let's come back. A 15 microcoulomb charge exerts a 4.5 Newton attractive force on the negative 20 microcoulomb charge. So here we have two objects that they are charged by. The first one, and there's a second one. The first one, it is 15 microcoulomb. What does it mean? Times 10 to the power -6. This is for the first one. Now for the second one here, we have a 20 times 10 to the power -6 also. So both of them, one is charged with 15 and the second with 20. Now, as you see here, we have a positive 15 and negative 20. These signs will not be written in finding or in solving the formula. It just only tell me that if they are attractive or repulsive for some forces. Okay, so don't substitute with positive and negative sign. So the first one here, it is a positive charge, and the second one here, it's a negative charge. And don't evaluate this positive and negative charge in the formula. It just only tell me that here the force or the type of force between them is an attractive force. Why it's attractive? Because we have a positive and negative charge. Now, in this question here, they told me that you have two objects. Both of them are charged, but and the force between them, there's a force now between them, which is 4.5 Newton. Show me that the charge separated by 77 centimeter. So here they give me the charge or the quantity of the first charge, the quantity of the second charge. They give me the force, and he asked me to find the distance. So let's choose let's write now our formula. F K Q1 Q2 over D squared. Now F is given, it's 4.5 equal K. What is the magnitude of K? It is 9
times 10 to the power 9.
Yes, 9 times 10 to the power 9 times Q1. What is the Q1? It's 15 times 10 to the power -6. Q2, it's 20 times 10 to the power negative 6. As I told you, don't substitute or don't evaluate the positive and negative sign. Now over D. D is unknown. So now D squared is 9 times 10 to the power 9 times 15 to the power negative 6 times 20 to the power negative 6 over 4.5. This is now for D squared. But I want D. So to cancel the D, or to find D only, let's put them under the square root.
Hi, Miss.
So
Good
put them
afternoon.
now under the square root like this. After that, if you're multiplying now 9 times 15, so how we solve it? Now multiply 9 times 15 times 20, divide by 4.5, 9 times 15 times 20 times over 4.5. This numbers now, it will be 600 times. Let's now add multiply the exponents. Since we have now the power 9, negative 6, and negative 6, and all the bases are the same, we will add the exponents. So it will be times 10 to the power negative 3. Now this answer is for D, under the square root. So D is equal the square root of 600 times 10 to the power negative 3. So the square root of 0.6, it will be 0.774 meter. So which is 77.4 centimeter. And that's what I want to prove. Is it clear?
Yes, teacher.
Yes, Miss.
So here I will repeat. As you see, we have two objects that they are charged with 15 microcoulomb and 20 microcoulomb. Now you have to find now the force between these two charged particles. They told me that the force is 4.5 Newton. I want to find the distance. How can I find the distance? Just now evaluate with this formula here. K is 9 times 10 to the